Okay, so storage. Everybody loves storage. If you don't love networking and you don't love everything else, you must love storage. So I can't take full credit for what we built here for storage today. That goes out to our Ottawa office represented by Jenn. I'm here to present it for her because she couldn't make it out today. And the kicker is, I'm just getting over a cough, so my voice isn't what it should be. So forgive me for that ahead of time. But let's try and understand storage for GKE-OP. What we decided to try out for this particular demo was we did one user cluster in GKE-OP, consists of Portworx and Robin. There are other options. You could have gone with something like Rook, which brings you Ceph. The underlying storage that Portworx and Robin give you right now, from what we understand, are not too open source, so we don't know what the file system is beneath it, but we could make some guesses, but that's not important. What's important is it's giving us something similar to what we would expect as if you were requesting storage from the cloud, which is what we're after. Just some quick overview of what the both of them are giving us is Robin.io has a lot of capabilities that if you were to take that and assume you're in the cloud, that's kind of what some of what you're getting. So the key one that Robin has to differentiate is snapshot capabilities for the combination of the app and the data. So it kind of makes that linkage and makes it portable. And cluster-to-cluster data movement. So you could, in effect, take an app and its PVs and shift it across clusters seamlessly with what Robin gives you. With Portworx, it has its own unique differentiators. How you would describe something like object block and object rehydration is when you could take something that's block, change it to object, and then bring it back to block to make it portable. Another one is RWX volumes and the ability to just do object storage, a lot like what you want with S3. Another key point is they both do encryption. One more that Portworx does differently is, I think QoS might not be the perfect term for it, but it sort of does per application traffic shaping. Resilient storage for GKE-OP. The answer is yes, we're trying to simulate as much as we can cloud storage, the way you just ask for it and you get it. You can't really absolutely simulate that though, because then you're talking about getting multi-region, and you're only going to be able to put storage where you have a VMware cluster where you've got GKE-OP running. That is for everything that you want on-prem. So, I mean, you have a different case of what you get with failure domains, regions. You don't get your near G-Cloud magical capabilities, but you can get pretty close. You don't get endless capacity, but pretty much everything else is up to whichever storage provider you pick. Nearly cloud-like resiliency is definitely something that we've seen we can do with these storage providers. So if it has the similar set of capabilities for attaching the PV to the app and kind of making it seamless, like I was surprised with how much we didn't have to think about the storage layer, whereas I'm coming from previously looking at external storage and making linkage to the pods with deployment configs that have storage mounts and so much to think about. But with this, we really didn't have to think about it as much. Before I go into the demo, I did want to go over quickly what we're showing, because it's a little bit of a head case. So there's a 6-node user cluster, 3 of which are running Portworx, 3 of which are running Robin. In order to make Portworx run, it needs its own etcd that lives on the same disk that you give the node for storage. That runs in a daemon set. The Portworx runs in a daemon set. Robin runs in a daemon set. It runs to have that same common storage plane for all of its nodes. It uses a combination of console and Postgres, and that runs on a separate 40 gig disk. And the disk for storage is yet another separate disk. Each of the storage disks were 100 gigs, 3 and 3. And for each set of 3, so for each provider, we provided a MySQL instance pod. And everyone's contention lately is, do you put databases on Kubernetes? And most people are saying, let's drop it into VMs because that's where we're mostly safe. Now, surprisingly enough, and I'm going to kind of ruin the kicker here, is what it takes to set up database replication, be it in the cloud or on-prem, is a good bit of work. And you can expect several minutes of downtime for the replication to kick in. You'll see how fast it works when we try it out. it was actually quite impressive. In the background, because I like Sysdig too, the store demo cluster here, what I did is I gave it a network overview so that we can see kind of what's going on. Unfortunately, I don't really have a way of splitting screens and showing them all at the same time. And we have to see a lot of things all at once to watch this happen. So I'm just going to show you what we're doing here. So in this window on the right, I'm doing a select for each of those set of pods against each storage product. So the one on the left is Portworx. The one on the right is Robin. And if you want to remember, it's Robin R right. So that's the one on the right. Portworx is on the left. So this is an every 2 seconds doing a select against the database. There's no caching. I'm going directly against the Kubernetes service. There's really nothing to hide there. So what I'm going to do is I'm going to let the storage make its own association with the pod and do its thing. So I'm going to delete the pod and also cordon off the node. Now I expect, this is the Portworx one, so the one on the left is going to go dead for a couple seconds and then come back. And then we can compare that to what we typically would see if it was database replication failing over. Okay, node cordon, pod deleted. So the one on the left should see a failure. And if it doesn't, I'm going to cordon and delete yet another one. Okay, so there's the failure. And I expect this to come back the moment that Kubernetes can bring back that pod. And the association to storage should come back right along with it. In the meantime, I'm going to go and destroy Robin as well. So you see the Portworx one on the left came back. So that was reasonably quick. I think if it wasn't for the on-off nature of the connection, I think you would have seen it come back in a few seconds. So when I was testing this up until this morning, it's a matter of seconds between when you see the pod connection to the storage and the node fail off. And then maybe at most 7 seconds later, the database is reconnected to the pod and the pod's able to receive selects again. And just that 7 seconds alone is something that I would think is very bearable for a database to see happen. Now, as long as the app that you're running can take into account those 7 seconds, to me, that's a lot faster than what it takes for normal database replication in the order of minutes to occur. Through thorough testing, I've found it quite amazing that you could take databases, throw them in Kubernetes, whereas everyone else has been pretty scared to do this before, and now you can do this and not even have to bother with database replication, just rely on fully replicated resilient storage that makes that cohesive match between the app that wants the PV and the PV itself. So underlying all of this, both storage providers gave us triple replication and full visibility into, consumption patterns. And you can see all of the same stuff. If you were to pull up like Sysdig and look at storage consumption, you'd see the same volumes as PVs and such. It all ties in quite well. We were really pretty surprised. And that was a point that Jenn said she wanted me to drive home, is that who needs database replication anymore when you can do it this way? That's pretty much the demo. The stuff we were working with is right there, portworx.com, robin.io, Sysdig, and Google Cloud.